Now, this illustration deals with conductor constructions and applications. Now, when an individual wants to know the characteristics of the insulation of a conductor, they naturally would reference Table 310.4a. But if they did not need that information, then the designer, installer, or inspector could just go to 310.6 and 310.10 in the NEC, and this information for using the insulation in certain areas is illustrated in how we would color code or identify those conductors. Now, but notice if I was using, say, THHN, well, the column 2 in the illustration shows that it's fire retardant, heat resistant thermoplastic, rated for 90 degrees C, maximum temperature. It can be used in dry and damp locations. It comes in sizes 14 through 1,000 kc mil, and it has a nylon jacket or equivalent. And notice this cable is mostly used and functions well in areas where it's very hot. Temperatures, you have a high temperature. Now, if you drop down, though, and look at XHHW, notice in column 2 that the insulation changes. It's flame retardant, moisture resistant, thermoplastic. It's good in 90 degrees C, dry and damp location, and used at 90 degrees C for correction or adjustment factors to terminate, say at 75 degrees C, as you see in the illustration, or 60 degrees C. It's very good 90 degrees C insulation to use with electrical discharge lighting, as we find these rules and or requirements in 410.68. We list that so you can see that. And THW is good for wet locations. It is also good for 75 degrees C temperature, thermoplastic. But let me tell you a little story I got into. The first time I went up on the slope of Alaska to do a class, you know, things are designed a little different up there because it can get down to, 50 below zero, wind blowing at 100 miles an hour. It's nothing to be 35 or 25 below zero. And the group of electricians asked me, said, "Hey, Stallcup, could we use THHN up here?" And I said, yeah, you could do that. And they strung THHN between 2 buildings and XHHW. Let it stay there all night long with that temperature dipping down like that. Next morning, the foreman and I and some of the guys would have breakfast together in the cafeteria. And the foreman, he said, "Hey, let's go outside just for a moment. So go in, get your coat and your hood on. So we're just going to step out for a minute." And he stepped out there and he took his Kleins and he hit that THHN and it started breaking. The insulation started cracking. In some cases, just peeled and fell off. And he walked over there with those Kleins and hit that XHHW. Nothing happened. And he looked at me and he said, "Now, can we still use THHN up here?" Well, they'd been picking at me all week. So I said, "Oh, yeah, but only inside the building." See, I kind of punted there. And he said, "Well, now you got me there, but you couldn't use it out here, could you?" I said, "Well, no, I think your demonstration showed that." So that is why if you had conductors on the roof, like in Arizona, exposed to very high temperatures, that the exception in 310 that we'll see and look at would allow XHHW/2 to be used in the raceway system without any correction factors at all being applied because of the high temperature that this conductor has. If you look it up in the UL White Book electronically on UL, if you type in ul.org, it'll come up, and you type in the research window the UL White Book, and it comes up, and you can look up this XHHW and XHH/2 and see how high a temperature that they will take before any type of damage to the insulation can occur, but also how low the temperature can get below zero without creating problems. Now, this used to be tabled in the 2017 NEC 310.104A. It has been renumbered and relocated like previous editions of the code, and it's table 310.4A. But again, if you don't need all these characteristics of construction and application of the installation, just go to 310.6 and 310.10, and you would have the information, and it'll even send you to the section you need to look at to determine color coding and identification of the insulation on the conductors. And it'll also refer you to the sections that you would look at for wet, damp, dry, insulation exposed to the sun, that kind of thing. And that's all in those two sections, and you don't have to remember all these sections if you just remember when you deal with conductors and conductors insulation, look at 310.6 and 310.10. That should be embedded in your mind because it's just two sections when you're wanting to obtain this type of information. And Figure 8-20 illustrates the conductor construction and applications of a conductor based upon its insulation in size.